Hi, in this video I want to talk about the circle equation in analytical geometry. Now the equation has the following format: x minus a squared plus y minus b squared is equal to r squared, where a and b are the turning point formula, or the turning point coordinates rather, and we have r as the radius of our circle. So if we were to take an example of this where a is 0 and b is 0 and r is 2, what would this look like on our diagram? So we'd get a circle that's like this, except the center would be more like that. So I can't get it to be exactly centered, but the idea is there, where any distance from the point, from the origin up to our circle, the circumference of our circle, that will amount to 2 units. So this is our y-axis and that is our x-axis. And now we want to try and compare this circle equation to the other equations that we usually work with. This circle equation currently can be defined as x squared plus y squared is equals to 2 squared, which is 4. So this is our current equation, and we don't necessarily have to write it in terms of y is equal to the square root of r squared minus x squared, because it makes more sense in this format, as it's the relationship between x and y that continuously should give us 4, right? So any combination of x, not any combination, but x has to be paired with a y such that we get a radius of 2 rather not 4. So the other principles do apply, though. We can still translate our graph. So the translations, as you would probably guess, are achieved by changing the values of a and b. So simply moving our value of a and our value of b, we're able to translate our graph left and right, then up and down. And then in this case, it will be as follows. So let's take an example real quick. If we take, let's say, for example, we take x minus 3 squared plus y minus 1 squared is equal to 9. This is a circle with the center at 3 and 1. I know you might be tempted to say, okay, it's at minus 3 and minus 1, but that is not the case, because again, in this case, we have to take where x minus 3 is equal to 0 to actually find the value of the coordinate itself. So it's been shifted 3 units to the right in this case. So that would be 1, 2, and 3, somewhere here. Then we shift this graph 1 unit down, because or 1 unit up actually. So that would be somewhere over here, and this will be the center of our circle. Then we draw our circle. Could say looks something like that. Move it up a little bit, and then this is the function, or not the function, but the circle equation, that is x minus 3 squared plus y minus 1 squared. And I'm avoiding using the word function because we are not under functions. Plus, if you watch the video on testing functions, by performing this vertical test, you would see that, okay, for one x input, I'm getting 2 y outputs, which means that that is not a function that I'm dealing with. So that's that. That's how you translate the circle equation. You should also be fairly confident in solving for unknown variables. So maybe sometimes you aren't given the r squared and you asked to calculate it, and maybe you know what the center will be, and maybe they give you one of these points. Because remember, this is analytical geometry. You can get straight lines, you can get various types of lines in here, and they can give you the equation of this line to say maybe this is y is equals to minus x something something something. So the procedure you'd have to follow is you'd have to find what the x-intercept of this function will be, the straight line. Once you have that, then you use that coordinate, call it b, along with o, which is the center of the circle, in order to find what the distance will be. So using the distance formula from the previous question, we can figure out what the distance is, you square it, then you put it in. So you should be able to be familiar with using the formulas from the previous video. You also get instances where you don't know some of these, like you wouldn't know what b is, but it's the same procedure. We know what the distance from O to B will be, because O to B is r, and r is √9, which is 3. So if you know the distance from O to B, and you know the coordinates of O, well, you know one of them, you know this will be 3 and this will be B, but you know both coordinates of B because you worked out the x-intercept, so that would be 0 and that would be something. For now, let's just call it x1. So you know 1, 2, 3 coordinates, and within the distance formula you need there's only the distance and the 4 set of coordinates, of which we have 3 of them, and the distance, so we can solve for b by making that subject of the formula. So your equation would look something like this. 3 is equal to, let's just say x1, for all intents and purposes the value is 3, but maybe let's make it 2. So we make that 1, 2, yeah, 2 would make sense. So 3 is equal to, because the formula for distance is d is equals to the change in x, x2 minus x1 squared, plus the change in y, y2 minus y1 squared. And then you would put that value in there and work out what the unknown value for b is. But then remember that instead of going this long method, you can literally use this formula as it is, because once you have the coordinates for b, you can plug them into x and into y and also solve for b. So I'm pretty sure you can see kind of the similarity between the distance formula and the circle formula. The distance formula is basically saying that we can have different values of x and y, different pairs of x and y, that will always give us a distance of 3 units from this specific center. So it's basically a lot of distances, and all of these are pairs of points that would satisfy this equation. But yeah, you don't need to know it too in depth, but being aware of these similarities can be the difference between you answering certain application type of questions and not being able to. So that's it for circle equation under analytical geometry.